In order to get ready for our Unit 2 exam, let's review a couple of the skills that will be on that test. The first question we're going to look at is 18, and this is going to be megawatts, is equal to how many watts? So the units that we're working in are watts, and we want to go from megawatts to our base unit of watts. So we have to know the relationship between the prefix mega to the base. There's a mnemonic device that can be used to help remember the prefixes. So I just want to review that really quick. So in order to go up to mega, you have Mighty King Henry died by, and then this goes on to say drinking chocolate milk. But we don't really need this last part because we're already at mega and our base. And let's talk about why. Alright, so Mighty King Henry died by drinking chocolate milk. So here's your base for whatever unit you're working in the metric system. So then with respect to the base, when you go to the right, you have your deci, centi, and milli. Going to the right, into these bigger units, you have deca, which would be DA. So this, as a reminder, this is deca, and then over here to the right, that was deci. Alright, so Henry is hecto, or H. King is kilo, or K. And then king is actually at 10 to the 3rd power. We do a jump to the 10 to the 6th power for mighty, which is capital M. So on this one, I'm going from mega to my base. So the relationship is mega is 10 to the 6th power of whatever your base is. So that means in this number, which right now I'm given 18, we're going to go 6 decimal jumps to the right. So 1, 2, 3, 4, 5, 6. That means I'm going to need a bunch of filler zeros in here. So this would be then 18 followed by 1, 2, 3, 4, 5, 6 zeros. Put commas every 3. So this is going to be then 18 million watts. If you wanted to set this up a little bit more formally using conversion factors, it would be 18 megawatts. I would put that over 1. I'm trying to get out of megawatts and into my base unit of watts. And the relationship is there's 10 to the 6 watts in 1 megawatt. So 10 to the 6 watts in 1 megawatt. The megawatt units will cancel. And then multiplying 18 by 10 to the 6th power, again, means I'm going to move the decimal point right 6 spots. So if I have 18 followed by 1, 2, 3, 4, 5, 6 zeros, I get the same answer as I got before. Because this is such a large number, we will tend to write this maybe in like scientific notation. So this number in scientific notation, I'm going to pull off the significant digits, which is the 1 and the 8. I put the decimal point after the 1 but before the 8, so that first number is bigger than 1 but less than 10. I'll write times 10, and then I'm going to need to see then how many jumps it takes for me to get to the end of this number. So 1, 2, 3, 4, 5, 6, 7 jumps to get to the end. So that's the exponent on my power of 10. And because I'm trying to make a big number where I'm jumping right, that exponent will be positive. So your final answer, you could either write 18 million watts or 1.8 times 10 to the 7 watts. For additional review on this type of question, you could be reviewing the prefixes, which was talked about in 3.1. 3.2 talked about the basics of converting inside of the metric system and moving the decimal point back and forth by looking at the prefixes. And then specifically watts as a unit of measure was explored in section 3.5. So, all right, so let's try this again. For number 2, we're going to look at converting 12 decigrams to milligrams. So this is going to be over units of mass. And again, for the prefixes, you could review 3.1. And then in 3.2, I got a little bit more into how to look at the prefixes in order to figure out how to move the decimal point. And then specifically looking at grams as a unit of measure was talked about in 3.3. So I could come back over here to the same mnemonic device that I had over here. On this particular problem, I'm trying to get from decigrams to milligrams. So here's decigrams right here. I'm trying to get to milligrams, which is over here. So in order to get from deci to milli, it's a jump of right 2 spots. So I could come down here to my number, which was 12. The decimal point was after the 2. If I jump right 2 spots, I'm going to need some filler zeros, so that I would end up at 1,200, and then the units I'm in now would be milligrams. If you wanted to set this up using a little bit more of a formal conversion factor, you would put your 12 decigrams over 1. And the relationship between deci and milli when working in the metric system, okay, because it's 2 off in terms of the exponent, there would be 10 squared milligrams in 1 decigram. My decigram units would cancel because they're on the diagonal. And then multiplying 12 by this power of 10 means I'm going to move the decimal point right 2 spots. So again, if I move the decimal point right 2 spots, I end up with 1,200 milligrams. All right, very cool. How are we doing so far? Are we doing okay with the conversions in the metric system and the prefixes and how to move the decimal point? Let's take a look at this next one. So question number 3, 175 liters is equal to how many cubic meters? So we have a relationship that was explored. We looked at liters as a measure of volume in section 3.4. And in that section, we explored the fact that 1 liter is equivalent to 1,000 cubic centimeters. So we can use that relationship to convert. Now, in this case, I want to get to cubic meters, but once I get my answer in cubic centimeters, it's then fairly easy then to go from cubic centimeters to cubic meters. All right, so here we go. The given information, which is 175 liters, I'm going to put over 1. Now I'm going to use my conversion factor. Liters is what I'm trying to get out of, so it's going to go on the diagonal of where it was, and the relationship is 1 liter is equivalent to 1,000 cubic centimeters. The liters units will cancel because they're on the diagonal, and now my answer would be in terms of cubic centimeters. No, I don't want cubic centimeters, I want cubic meters. So there's a couple different ways to do this second conversion. I like to think I'm converting out 3 centimeter units. So I'm going to set up 3 conversion factors, each of them with centimeters in the denominator because that will be on the diagonal of where it was, which right now it's this, my cubic centimeters are occurring in the numerator. Now I'm going to ask myself, what's the relationship between centimeters, which is what I'm in, and meters, which is what I want to go to? And there's 100 centimeters in 1 meter. So 100 centimeters in 1 meter. I'm going to use that to finish out all my conversion factors. So my cubic centimeters will cancel with my 3 centimeter units that I have in the denominator, and then my final answer will have meters times meters times meters, or cubic meters, for my final units. All right, very good. So let's take a look then at what numbers that I have in order to compute the numerical part now that I know that I have the right units. So up here in the upstairs, in the numerators, I have 175 times, and as opposed to writing 1,000, I'm going to write 10 cubed, just to write it in the exponential form. This is not the only way to answer this question, but I just want to draw back to working with powers of 10 and how the exponents can make our lives a little bit easier. Downstairs, I have 100, which is 10 squared. times another 100, which is another 10 squared, times another 100, which is another 10 squared. Because I have the same base right here, we can add those exponents. So 2 plus 2 plus 2 is 6. So ultimately, downstairs, I end up with 10 to the 6th power. Working with things in exponential form, because I have the base of 10 occurring both upstairs and downstairs, what I can do is I can subtract these exponents. So I would end up with 175 times 10 to the negative 3rd power. And then what this is going to tell me is it's going to say take the decimal point in this front number and move it left 3 spots. So this exponent says move the decimal point left 3 spots. So if I take the decimal point and move it left 3 spots, I would end up at 0.175. And then the units, again, would be in cubic meters. All right, again, that was not the only way to analyze that question. You could work with all of those powers of 10 with all of those zeros in there, just to review a little bit about what the exponents tell us. All right, next one, number 4. 1.8 cubic feet into cubic inches. So I'm going to take my 1.8 cubic feet and put it over 1. And again, I'm going to kind of play the same game I just did up here. I have 3 feet unit I want to cancel. So I'm going to set up 3 fractions, each of them with feet in the denominator, so it's on the diagonal of where it's originally occurring, which is right now in the numerator. And now I'm going to ask myself, what's the relationship between feet and inches? Well, in 1 foot there are 12 inches, and that's going to finish my conversion factor. In 1 foot there are 12 inches, and I'm going to repeat that 3 times for each of my conversion factors. There is 1 foot in every 12 inches. So my cubic feet will cancel with the feet in the denominators. I'm going to be left with inches times inches times inches, which is ultimately going to be cubic inches. So now that I have the right units, let's go ahead and do the computations. So 1.8 times 12 times 12 times 12 is going to be 3,110.4. Now the directions had said to round your answers to 3 significant digits when necessary. So this is going to be the first one I'm going to need a little bit of rounding. So looking at my significant digits, the 3 is significant, the 1 is significant, and this 1 is significant. And then because this number is not 5 or bigger, I'm not going to round my last significant digit up. So my final answer would be 3110. And then my units are cubic inches. All right, so that would be my final answer. All right, number 5, I want to convert 25.6 kilograms per square centimeter to pounds per square inch. So I have 2 units I have to convert out. I have to convert my kilograms to pounds, and I have to convert my square centimeters to square inches. And it doesn't matter which conversion you do first, ultimately we're going to have to convert out both of them. Now when I go to set up the original problem, I'm not just going to put it over 1 because my denominator is going to have units. So I'm going to have 25.6 kilograms over 1 square centimeter. I'm going to convert out my kilograms first. And if you had seen my earlier videos for this, by the way, this was a type of question that was explored in 3.7. Converting US to metric. The conversion factor I used was that 1 kilogram was equal to 2.2046 pounds. So this conversion factor has an accuracy of 5 significant digits. All right, so this is the conversion factor I'm going to use. Kilograms is what I'm trying to get out of, so it's going to go on the diagonal of where it is. And then I'm going to relate my conversion factor. I've got 1 kilogram is equivalent to 2.2046 pounds. The kilograms on the diagonal are going to cancel, and now I've got pounds in the numerator, which is what I want, so I'm good there. Now I'm going to convert out from centimeters, specifically square centimeters, to square inches. I have 2 centimeter units I need to convert out, so I'm going to set up 2 fractions. There we go, with centimeter information in the numerator. because it's on the diagonal of where it originally is. So since it was originally in the denominator, the diagonal now is going to be the numerator. And the relationship between centimeters and inches is another conversion factor. We need to know that 1 inch is equivalent to 2.54 centimeters. So that will finish my conversion factors. So I'm going to put 2.54 next to my centimeter labels, and then 1 inch is going to go on the denominator. So then when I'm done here, my square centimeters will cancel with the 2 centimeter units in the numerator, and I'll be left with inches times inches, or square inches downstairs, which is what I wanted. Okay, very cool. So now that I know I have the right units, now let's actually do the computation. So we're going to do 25.6 times 2.2046 times 2.54 times 2.54. Downstairs, I just have a whole bunch of ones. So there's nothing really exciting going on downstairs. When you pop that into your calculator, you get 364.11385, and there's some more numbers after that. My units would be in pounds per square inch. We want to keep this to 3 significant digits. So 1, 2, 3 significant digits. Since the number in the 4th spot is a 1, and that's not 5 or bigger, I'm not going to round the number in the 3rd significant digit spot up. So my final answer would be 364, and then my units would be pounds per square inch. Now, by the way, if you had used a conversion factor here that was lesser, so let's say if you used that 1 kilogram was equal to 2.20 pounds. All right, so this is only going to be significant to 3 decimal places. If you had used this, you would get for your final answer 363.354, and then there's some numbers after that. But then on this one, if you round this to 3 significant digits, because the value that is in the 4th spot is a 3, we would not round this up, and you would get 363, and then my units would be pounds per square inch. So you can see that's a little bit off than what I got. I got 364 pounds per square inch because I had more significant digits in my conversion factor. So there's a little bit of latitude here, but obviously we should be very, very close, and we're only off by significant digits depending on what conversion factors are used. And by the way, that skill was in 3.7 if you want some additional review on that. To convert the cubic feet to cubic inches, that was also in 3.7 for additional review on that as well. And then the volume was talked about in 3.4. Looking at mass was talked about in 3.3. And then 3.1 and 3.2 served the basis of all of these metric conversions that we're doing, and the idea about how to set up conversion factors.